Okay, let's look at plotting this equation 3x plus 2y equals 10 using the slope-intercept form. What we're going to do is we're going to first of all solve for y. Then we're going to see that it is in the form y equals mx plus b. That is the slope-intercept form of the line. M is the slope of the line, b is the y-intercept. It satisfies the point satisfies the equation with 0b. When x is 0, y will be b. Alright, so let's do this. First of all, what we're going to do is we're going to subtract 3x from both sides of this equation. When I do that, what I end up getting is 2y equals negative 3x plus 10. Now what I'm going to do is I'm going to divide everything by 2. If I divide this piece by 2, I will get y. If I divide the negative 3x by 2, I'll get negative 3 over 2x. If I divide a 10 by 2, I'll get 5. Now it's in this form, y equals mx plus b. So I know now that the slope of this line is negative 3/2, and the y-intercept, b, is 5. Alright, so I come over here to this graph and I come up 1, let me change colors. 1, 2, 3, 4, 5. This point is the point 0, 5. Okay, so that's where that line is going to cross the y-axis. Alright, now I know that my slope is negative 3/2. Remember that negative slope will fall as it moves to the right. So I know this line is going to decline as I move to the right. I'm going to go over 2, 1, 2, and then I have to go down 3 in order to get it to fall. So there's a second point. Now I should be able to draw a line through those 2 points and I will have my graph. So that line looks like this. Now every point on this line will make this equation right here a true statement. And every pair of numbers x, y that makes this thing a true statement will be on this line. Alright? Let's try this. Let's suppose that I go over 4 and down 6. Now that's equivalent to 3/2. So from here, if I go over 1, 2, 3, 4 and down 1, 2, 3, 4, 5, 6, this point is on my line. Now that point should be 6, 1, 2, 3, 4, negative 4. That point's on my line. Let's try it out and see. Does 3 times 6 plus 2 times negative 4 equal 10? That's the question that I have. Well, that's 18, and this is negative 8. Looks to me that's going to be equal to 10, so it does check out. Once again, every point on my line will make that a true statement. Okay, let's go on to the next one. Let's change our equation a little bit. Let's use, how about 2x minus 5y equals 15. Once again, I will subtract 2x. Now be careful, you've got a minus sign right here. Don't drop it. See that minus sign? Keep in mind that you've got to hang on to that. So it'll be minus 5y equals, I subtracted 2x, and I've got plus 15. Now I'm going to divide everything by negative 5, so this becomes y. Negative divided by negative is positive, so I've got 2/5 as x, and 15 divided by negative 5 would be negative 3. So that means my slope is going to be 2/5, and the y-intercept, b, will be negative 3. Now keep in mind, I know that on a slope, positive slope, if it's going to be negative 3, it's going to be somewhere down here. It's going to climb. It's got to climb because it's positive slope. Here we go. 1, now I'll do it in red. 1, 2, negative 3 is right here. This point is the point 0, negative 3. That's the y-intercept. Now from there I'm going to go over 5 and then up 2. 1, 2, 3, 4, 5, and up 2. I could go 6, 7, 8, 9, 10, and up 1, 2, 3, 4. Could, but I don't. Alright, so let's see what this thing looks like. Alright, now keep in mind that 2/5, 4/10, 6/15, all of those are the same slope. So you could use any pair of numbers, any combination of numbers that suits you. Sometimes the way the graph is set up, it's easier to go from here back 1, 2, 3, 4, 5. Just remember you got to have a negative slope, so you'll have to go down too. You're still going to get that same value of negative 2/5 on the slope. So that's what that one looks like. Okay, so we end up with one with a positive slope, which you see climbs. This one grows, gets up higher as we go, and a negative slope falls as we move over. Okay, so let's look at this one. Now on this one, what I want to look at is, suppose, let's take that same, that first equation, and it is 3x plus 2y is 10. But I want to change it just a little bit. We're going to say that it's 3x plus 2y is less than or equal to 10. Now we're going to do this exactly the same way. We're going to subtract 3x and then we're going to divide by 2. And I still get negative 3/2 as my slope, and I still get 5 as my y-intercept. We're going to get this same line here, a positive 5, 1, 2, 3, 4, 5. Here's my point 0, 5, and I'm going to go over 2, and down 1, 2, 3. Over 2 and down 1, 2, 3. And now when I draw the line through those 2 points, I'll get exactly the same line. Now the difference is, this one is an inequality. It's not an equation, it's an inequality. Well, what's the difference? Well, what we have to do is compensate and figure out which field of these numbers we're going to use. Okay, just like before, here's my line. Move that a little closer. Here's my line. with a y-intercept of 5 and a slope of negative 3/2. Notice that it falls as we go to the right. Now the difference is it's an inequality, so what I must do is check to see which points lie. Now there's different ways of looking at this. Your author will say because it's less than, that tells you. I don't do that. What I was taught was to take this point right here, which is the point 0, 0, and plug it into the original equation. So 3 times 0 plus 2 times 0, is that less than or equal to 10? That's the question that you have. Well, that's certainly true because it's 0 is in fact less than 10. Well, what that means is all of these points down here are shaded. Any of the points down here will make this line a true statement. By the same token, any of the points up in this, and let me just so you can keep track of it, any of these points up here will not be true. And I can pick one, it doesn't matter what I choose. Let's choose 1, 2, 3, 4, 5, and up to. Let's take this point right here. It is the point 5, 2. Does 3 times 5 plus 2 times 2, is that less than 10? That's the question that I have. Well, that's 15 and that's 4, and I think you can see clearly that 19 is not less than 10. So we see that that's false. And so none of these points up here will work. But because this one does, all of these points below that line will work. That's the concept. That's the concept of the inequalities. The only other issue that you have, and we'll take a look at it, is that if you have, I'm going to give you two things at the same time, and that is if you have a negative coefficient of y and you have strictly less than, what happens then? Let's suppose now that I've got an inequality such as this one. Let's suppose that I've got two x 5y is strictly greater than 15. Now it's similar to this equation up here that we had earlier. This one up here, it looks the same as this one except that I've got an inequality sign. We're going to do exactly the same thing that we did with the equation. We're going to subtract the 2y, the 2x, so I'll have 5y is greater than negative 2x plus 15. Now, be careful on this one. Now, I'm going to divide by a negative. If I divide by a negative, this symbol changes. So you've got to be careful about that. If I divide by negative 5, that's going to become y. This will become less than. And negative divided by negative is positive 2/5, just like I did in the other example. And 15 divided by 5 is negative 3. It's exactly the same thing that I've got up here. Exactly the same thing. My slope, 2/5, and I know that the y-intercept is negative 3. Alright, so let's go to our graph and see what happens here. And I'll do this one in red so you can keep up with it. I know that my y-intercept is negative 3, and that's a little small, so let me zoom in just a little bit. -3 is my y-intercept. 1, 2, 3. Right here is my y-intercept. And 2/5, I'm going to go over 1, 2, 3, 4, 5, and up 2. 1, 2. There's a second point right there. Alright, so now I want to draw the line through those 2 points. Now here's the issue. When I draw this line, it won't be a line, it'll be a dashed line. Instead of drawing a solid line, what I will do is I will draw a dashed line. Now the reason that I do that, if I pick out any point on the line, well, I know that, what? I know that 0, -3 is a point on this line. But if I plug it back over here, 2 times 0 minus 5 times -3 is greater than 15. Let's see what we've got here. Well, what I end up with is 15 is greater than 15, and that's not true. Okay? So my problem is I can't have points on the line itself, so that's why I've got a dashed line. Up here, on the previous example, this point right here was on my graph. It is the point what? 0. Well, 3 times 5 is 15. 2 times 0, I did that wrong. It's 0, I'm sorry, 3 times 0 plus 2 times 5. If I do 3 times 0 plus 2 times 5, because that's my y-intercept right here, I know that that is less than or equal to 10, because 10 is in fact less than or equal to 10. I can have it equal. On the other example, where it was strictly greater than, because it's strictly greater than, I cannot have 15 greater than 15. That's not true. I do not want the edges. Okay, so now what? Well, go back to what I said. Take this number right here. That's 0, 0. Well, to shorten it, the question is 0 bigger than 15? And the answer is no, it's not. So that means that 0 is not on my graph, and it would be all of these points down here. Because 0 is not greater than 15, and what I did was I shortcutted it. The reason I do that is because that's exactly what it's about to be. 0 minus 0 is still going to be 0. That's why I use that origin. It's real. Is 0 bigger than 15? No, so 0 is not, the origin is not in it. It's going to be these values down. Okay, so to recap, let's take a look and see what we've got. To graph using the slope-intercept, you solve for y, and the coefficient of x is in fact the slope. Here's my slope right here, here's my y-intercept right here. You can plot the y-intercept simply by going up or down on the x-axis. In this case it was up 5, in this case it's down 3. Plot the slope. Remember that a negative, so I'm going to go over 2 and down 3. On this one, I've got a positive slope, so I'm going to go over 5 and up 2. That way climbs, this one falls. Now, if you've got inequalities, same concept. The only thing you have to watch out for is when you divide by that negative. If you've got less than or equal to, it's a solid line. If you've got strictly greater than or less than, it's a dashed line. And that's all there is to graphing using slope intercept form.